Hello friends, today we'll discuss a very important chapter in arithmetic, that is time, speed, distance. In this chapter we'll also discuss boat and stream and racage. Question related to race. Time, speed, distance chapter make an important integral part of aptitude test questions. To start with, first of all, we'll discuss about the three ratio that is required for doing many questions in time, speed, distance, that is basics. Then we'll discuss relative speed, average speed, passing and crossing, related questions, some aptitude based questions. After that we'll discuss question related to train, then boat and stream, race, and some question on clock also, that is basically based on circular motion and clock. So to start with, time, speed and distance, in short we say TSD. In short we say TSD, time, speed, distance. The basic equation is distance equal to speed into time. In short we say D equal to ST. First of all, I will discuss three ratio based on this basic equation. The first one, in this equation, when a speed is constant, what happens? See, when a speed is constant, like, see one example, if you are moving by your car with the speed of 40 km per hour, that is fixed. If you travel for 4 hours, then you will move how much? 160 km. If you move for 5 hours, then we will cover how much? 40 into 5, 200 km. So if you increase the time of travel, you will cover more distance. And if you decrease the time of travel, you will cover less distance, provided that speed is constant. It means distance and time are directly proportional. So when a speed is constant means distance by time speed, which is constant. We know that when a ratio of two quantity is constant, when a ratio of two quantities is constant, the two quantities are directly proportional. Means one increases, here distance increases, then other must increase, here time must increase. Or when distance decreases, then other quantity time must decrease. We write like this: distance is directly proportional to time, or we can say distance increases means time increases, distance decreases means time decreases. That is the concept. And if we make the graph of this is suppose time and this is distance D. Distance is directly proportional to time. Given that speed is constant, the graph will be a rising line. The graph will be a rising line from left to right. From left to right. Now, how we make ratio from this? You see. Suppose two cars are moving with same speed in same direction. First car cover D1 distance in T1 time. Second car cover D2 distance in T2 time. From this, our basic equation is d1 equal to s into t1. From this, we have the basic equation is d2 equal to s into t2. Divide this relation by this relation. So we have d1 by d2 equal to s into t1 by s into t2. S and s cancel. So we have d1 by d2 equal to t1 by t2. That is, ratio of distances covered equal to ratio of time taken, given that speed is same. Means speed is constant. So ratio of distances traveled equal to ratio of time taken. This ratio will be used for doing questions when a speed is constant. Now, second ratio we will discuss when time is constant, what will be the ratio, and third, when distance is constant, what will be the ratio. You see, the second one. Second one is when time is constant. When time is constant. Now, when time is constant, it means ratio of distance and speed, which is time, constant. And so, ratio of distance and speed is constant, means distance is directly proportional to speed. Means distance increases when speed increases, distance decreases when speed decreases, and vice versa. When speed increases, distance must increase, or when distance increases, speed must increase, given that time is constant. That is, suppose you have to move for 5 hours. Your car speed is 50 km per hour. What happens? You will cover 50 into 5, 250 km. If your car speed is suppose 60 km per hour, car speed has been increased, then in that 5 hour, you will cover how much? 60 into 5, 300 km. So distance traveled increased from 250 till 300. So when time is constant, distance increases when speed increases, or you can say distance decreases when speed decreases, and vice versa. And vice versa means when speed increases, distance increases. When speed decreases, distance decreases. So directly proportional. This is the sign of proportion, direct proportion. Now what happens? If you draw the graph, suppose this is a speed, this is distance. Again, graph will be rising from left to right. Okay? Graph will be rising from left to right. Now, ratio. Suppose two cars are moving for same time. One cover d1 distance with s1 speed, other cover d2 distance with s2 speed. Now, from this, you have d1 equal to s1 into t, this ratio, this relation. From here, you have d2 equal to s2 into t, this relation. Divide this by this. You have d1 s1 into t by d1 by d2 equal to s1 into 2 by s2 into t. Now t and t cancel, so you have d1 by d2 equal to s1 by s2. That is, ratio of distances travel equal to ratio of speed, provided time is same. This ratio will be used while solving the question. I hope you understand this. Now, the third ratio is related to when distance covered is constant. when distance covered is constant. Distance covered is constant. That is a speed into time, which is distance, that is constant. Now see, you have to cover 200 kilometers, that is fixed. If you travel by your car with the speed of 40 kilometers per hour, how much time you will take? 200 by 45 hours. Next time you cover the same distance, that is 200 kilometers, with the speed of 50 kilometers per hour, how much time you will take? 200 by 50, that is 4 hours. What happens? You increase the speed, time taken decreases. Here, the distance covered in both the cases is same, that is 200 kilometers. So, when distance is constant, you increase the speed, time taken decreases. Other way, when we decrease the speed, the time taken will increase. Means, speed and time are inversely proportional. One increases, then other must decrease, and vice versa. One decreases, then other must increase. So, what we write? The notation is like this. A speed is inversely proportional to time. That is, a speed increases, time will decrease. A speed decreases, time will increase. If you make the graph, this will be, suppose this is time, this is a speed, graph will be falling, line from left to right. Now, ratio. Suppose two cars are moving same distance, traveling same distance. The first car with a speed s1 in time t1. The second car with a speed s2 in time t2. The two cars have traveled same distance. Now, in this case, the equation is d equal to s1 t1. In this case, equation is d equal to s2 t2. Left hand side same, so right hand side will also be same. That is s1 t1 equal to s2 t2. Or from here you have s1 by s2 equal to t2 by t1. And so this is the ratio which will be used in doing questions where distance covered is constant. That is ratio of a speed equal to inverse ratio of time. That is, here you can see this S1 correspond to T1, this S2 correspond to T2. So when distance covered is same, or you can say constant, ratio of a speed equal to inverse ratio of time. So that way I have discussed the three ratio, and that is based on this equation, given that one of these three variables is constant. Now how these ratio are used in questions, now I am discussing. See the problems which are based on these ratio, or you can say these ratio can be used for solving those problems. First problem is a man covers certain distance between his house and his office. By motorcycle. At an average speed of 30 kilometer per hour. 30 kilometer per hour. He is late by 10 minutes. He is late by 10 minutes. However, at an average speed of 40 kilometer per hour, he is early by 5 minutes. Find the usual time taken, or you can say normal time taken by him in reaching his office. Also find the distance between his house and his office. This is the question. Generally, you can see this question, this type of question in exam. Question is, a man covers certain distance between his house and his office by motorcycle at an average speed of 30 km per hour. He is late by 10 minutes. Late means what? From normal time 10 minutes more. From usual time 10 minutes more. However, at an average speed of 40 km per hour, he is early by 5 minutes. Find the usual time taken by him in reaching his office. Usual time means normal time. This is the first question here. And also find the distance between his house and his office. So there are two questions. What is the normal time generally the man takes, and what is the distance between his house and his office? We will discuss 2-3 methods. Certainly we will use ratio. See, before solving this, one thing here, all of you know that the unit of a speed is kilometer per hour or meter per second. Sometimes in question you have to convert from kilometer per hour into to meter per second, or you have to convert from meter per second into kilometer per hour. So how this conversion can be done? You can see 1 kilometer per hour means 1000 meter by 3600 second. If you solve, this is 5 by 18 meter per second. And 1 meter per second equal to 18 by 5 kilometer per hour. Now, whenever you have to convert kilometer per hour into meter per second, multiply by 5 by 18. And whenever you have to convert meter per second into kilometer per hour, multiply by 18 by 5. I hope you got this. Now I am coming to the solution of this question. You see, solution is like this. His house and his office. One day, a speed is 30 km per hour. He is late by 10 minutes in reaching his office. So, suppose normal time is t minutes. So, he takes t plus 10 minutes in reaching his office with the speed of 30 km per hour. With this speed. and next day he increased the speed and the speed is 40 km per hour. He reached his office 5 minutes early, means time is t minus 5 minutes. T is the normal time, or you can say usual time. See, in first case, the distance covered is same as the distance covered in this case. So what is constant? I am discussing first method. First method, that is with the help of ratio. What happens? The distance covered in this case, the first case, is same as the distance covered in second case. That is, distance between his house and office is same. So distance is constant. As you know that when distance is constant, distance covered is constant, ratio of a speed equal to inverse ratio of time. So we have 30 by 40 ratio of a speed equal to inverse ratio of time, that is t minus 5 by t plus 10. Because t minus 5 correspond to 40, t plus 10 correspond to 30. One thing note here, unit of a speed kilometer per hour, unit of time here minute. But I have used here. You know that ratio is a pure number, that is unitless. That's why I have used here, I have not converted these two into hour. Ratio is a pure number, it is without unit here. Now solve this, 0, 0 cancel. We have 3t plus 30, 4t minus 20. So t equal to 50 minute. T equal to 50 minute. So normal time taken is 50 minute. So we have found normal time, 50 minute. Now for distance. Normal time is 50 minutes. You can see with the speed of 30 km per hour, the time taken is 50 plus 10, that is 60 minutes, or you can say 1 hour. Or with this speed 40 km per hour, time taken is 50 minus 5, that is 45 minutes. Or you can say 3 by 4 hours. So in 1 hour, with the speed of 30 km per hour, the man will cover how much distance? Obviously 30 km. Or with the speed of 40, in 3 by 4 hour, man will cover how much distance? 3 by 4 into 40, that is 30 hours. So distance between his house and office is either 30 into 1 or 40 into 3 by 4, same thing, that is 30 kilometer. So that way we have found the distance between his house and office. First, distance covered in both the cases is same, so ratio of a speed equal to inverse ratio of time. From this we get normal time t equal to 50 minutes. Now here 50 plus 10, that is 60 minutes, 1 hour. Or here 50 minus 5, that is 45 minutes, that is again 3 by 4 hours, divided by 60 then. With this 30 speed kilometer per hour, in 1 hour how much distance is covered? 30 into 1, speed into time. Or with the speed of 40, how much distance is covered? That is 40 into 3 by 4, again 30. So the distance covered is 30 kilometer, or you can say distance between his house and office is 30 kilometers. This is the first method with the help of ratio. Now, next I am discussing second method. Second method we can discuss like this. We can do like this. See, what we can do. first of all, tell me the difference of time between these two timings. 15 minutes. Difference between timing is what? 15 minutes. Now, consider some distance between his house and office. You can take any distance, but for convenience, take the distance between his house and office as LCM of 30 and 40. LCM of these two speed, which is 120. So take the distance between his house and office as 120 kilometers, just for calculation convenience. Now, for covering 120 kilometers with the speed of 30, with the speed of 30 kilometers per hour, how much time is taken? 120 by 30, that is 4 hours. And for covering 120 kilometers with the speed of 40 kilometers per hour, how much time is taken? 120 by 40, that is 3 hours. So, difference between time is 1 hour, or you can say 60 minutes. Now, we can use unitary method. How? When difference, since difference is 60 minutes, distance is what? 120 kilometers. Therefore, when actual difference of timing is 15 minutes, what is the distance? Distance is 120 by 60 into 15, which is 30 kilometers. So, we can use unitary method. When difference 60 minutes, distance 120 kilometers. When actual difference 15 minutes, distance is 120 by 60 into 15, that is 30 kilometers. What I have done here? I have taken some distance between his house and office. You can take any distance. But for calculation convenience, I have taken the distance as the LCM of 30 and 40, which is 120 kilometers. Now, 120 kilometers covered with the speed of 30 kilometers per hour, time taken is 4 hours. 120 kilometers covered with 40 kilometers per hour speed, time taken is 3 hours. So, difference between timing is 1 hour. So, we can say difference 60 minutes, distance 120 kilometers. Difference in actual 15 minutes, distance is 120 by 60 into 15, that is 30. Just I have used unitary method. I hope you understand this. Now, when 30 kilometer distance is there, so 30 kilometer distance is covered with the speed of 30 kilometers per hour in how much time? 1 hour. That is, you can say 60 minutes. And so, t plus 10, 60 minutes. So, normal time is 60 minus 10, that is 50 minutes. I hope you understand this. 30 kilometer distance is covered with this speed in how much time? 1 hour or 60 minutes. That is t plus 10, 60 minutes. So, t equal to 60 minus 10, 50 minutes. Or you can use this one also. 30 kilometer covered by 40 kilometer per hour in how much time? 45 minutes, 3 by 4 hour in fact. 30 divided by 40. 3 by 4 hour, or you can say 3 by 4 into 60, that is 45 minutes. So, this is 45 minutes. So, t equal to 45 plus 5, 50 minutes. So, this way you can find the normal time. I hope you understand this. I hope you understand. This is the second method. So, this method is without ratio. In this method, I have not used ratio, just I have taken the LCM. Now, see the second question. Second problem is walking 4/5 of his usual speed, or you can say normal speed. A person is 10 minutes late. A person is 10 minutes late to his office. Find his usual time. Find his usual time to cover. Find his usual time to cover the distance. This is the question. Solution is like this. You can see. Walking 4/5 of his usual speed, or you can say normal speed. A person is 10 minutes late to his office. Find his usual time to cover the distance. See, this can be done with the help of ratio. How? Office. Suppose the person starts from this point. Normal speed is S, then normal time taken is t minute. But when a speed is 4/5 of his usual speed, that is 4/5 of the speed, he is 10 minutes late, that is t plus 10. The question is, what is the normal time? Means we have to find t. What happens? The distance covered in this normal case is same as the distance covered in this case. You see, distance is same in both the cases, so ratio of speed equal to inverse ratio of time. I am using the ratio when distance is constant, that is S by 4/5s equal to t plus 10 by t. This t plus 10 correspond to 4/5s. This t correspond to s. Now s and s cancel, so we have here 5/4 equal to t plus 10 by t, and if you solve, we have 5t equal to t plus 40, so t equal to 40 minutes, and that is the normal time. Just I have used ratio of speed equal to inverse ratio of time, because this t minute correspond to s, this t plus 10 minute correspond to 4/5s. So that way, with the help of ratio, we have got the normal time. Second approach is like this also. You can think like this also, that you can think mentally. In fact, that is, you see, when a speed decreases 4/5, a speed decreases, so a speed becomes 4/5 of the usual speed. Obviously, time will increase. How much? 5/4 of the normal time. Why? Because speed and time are inversely proportional. Why? Distance is same in both the cases, that is, distance is constant. 5/4 t equal to t plus 10. Now solve this. This is 5t equal to 4t plus 40, and that is t equal to 40 minutes. That is the normal time. The speed becomes 4/5, decreases, so time will increase just inverse 5/4 of this normal time, which is equal to t plus 10, and so we have got the normal time as 40 minutes. I hope you understand this. Now see the next problem. The next problem is two men A and B walk from P to Q. Walk from P to Q. A distance of 21 kilometer at 3 kilometer per hour and 4 kilometer per hour respectively. B reaches Q returns immediately. B reaches Q, returns immediately, and meet A at R. Meet A at R. Find the distance. Find the distance from P to R. This is the question. I will solve this question with the help of ratio. How? You can see. Two men A and B walk from P to Q a distance of 21 km at 3 km per hour and 4 km per hour respectively. B reaches Q, returns immediately, and meet A at R. Find the distance from P to R. The solution is like this. See, this is P, this is Q, and distance is 21 km. Now A and B start from here. A with the speed of 3 km per hour, B with the speed of 4 km per hour. B reaches Q and immediately returns and meet A at R. We have to find distance from P to R. Suppose this distance is x kilometer. So we have to find x. Now first of all, we have to see here what is constant. Most of the students say distance is constant. But see, distance covered by B is different from distance covered by A. So distance is not same. So distance is not constant. Now you can see here A and B started at the same time. B reaches Q and returns immediately. A travels towards Q and then B meets A at R. Means time taken by A is same as time taken by B to reach R. So what is constant? Time is constant. So here time is constant. You can see this is x, then QR is 21 minus x kilometer. Now time is constant, so ratio of speed equal to ratio of distances traveled. The distance traveled by A is x, that is PR, and distance traveled by B is 21 plus 21 minus x. You solve it and you get x equal to 18 kilometer. You get x equal to 18 kilometer. So ratio of a speed, that is 3 by 4, equal to distance traveled by A is x kilometer divided by distance traveled by B. This is 21 plus 21 minus x. And from here we get x equal to 18 kilometer. So distance from P to R is 18 kilometer. You have to note this again. The time is constant here. Why? A and B started at the same time. A and B meet at R, but B goes to Q and immediately returns. So time taken by B in reaching R is same as time taken by A in reaching R. So time is constant. That's why I have used ratio of a speed equal to ratio of distance traveled by A and B. And from here you get x equal to 18 kilometer. Now, second approach is like this. You can use options also. How? In option, 18 kilometer will be there. So, this is 18 kilometer. PR is 18 kilometer if you put option. So, time taken by A in covering 18 kilometer is 18 by 3. That is 6 hours. Now, same time is taken by B also. In 6 hours, B will cover how much? 6 into 4. That is 24 kilometer. That is 21 plus 3 kilometer. So, QR is 3 and PR is 18. 18 plus 3 is 21. Means A and B have met at R. I repeat again. In the option, 18 kilometer will be the option. If 18 kilometer you consider, then A has to cover 18 kilometer with this 3 kilometer per hour speed in how much time? 6 hours. In 6 hours, we will cover 6 into 4, 24 kilometer. That is 21 plus 3. So QR is 3, PR is 18. Sum is 21. Means A and B have met. And that option will be correct. So you can use your option also in solving this question. I hope you understand this. So that way I have discussed the 3 ratio and related questions. And the 3 ratio are very important, or you can say are very basic in solving the question of time, speed, distance, or in fact related topic, that is applied topic like boat and stream, train, or question on racing. I hope you understood the concept. You got the concept. That's all of this lecture. In the next lecture, I will discuss average speed, relative speed, and so on. I hope you enjoyed this session. Thank you.